In this lecture, I will solve some of the most important problems on E.M.F equation of a single phase transformer. In the previous session, I derived the E.M.F equation of a single phase transformer is E1 is equal to 4.44 into 5M into F into N1. This is called the primary induced E.M.F. The secondary induced E.M.F is 4.44 into 5M into F into N2. This 5M is called the maximum value of flux. The 5M is called the maximum value of flux that can be written as Bmax into AN, where Bmax is the maximum flux density. Maximum flux density in Weber per meter square. That should be equal to 5 max divided by AN, where AN is a net cross sectional area of the core. Cross sectional area of core. So I will explain what is meant by gross salary and net salary. Gross salary is your total salary. That may be a 30,000 per month. Some of the cuttings will be taken place. So that is the tax. After that, by hand, how much amount you are getting, that is called the net salary. Similarly, same way, we have a total area of the transformer, that is net cross sectional area of the core plus area of the insulation. But in an E.M.F equation of a single phase transformer, we should consider only net cross sectional area of the core. So replace 5 max with Bmax into AN in the E.M.F equation of a single phase transformer. E1 is equal to 4.44 into Bmax AN F into N1, and E2 is equal to 4.44 into Bmax AN F into N2. So coming to our problems, a single phase transformer, that is 2200 by 250 volts 50 Hz transformer, has a net cross sectional area of 36 square centimeter. So net cross sectional area is 36 centimeter square. That means 36 into 1 centimeter is equal to 10 to the power of minus 2 meters. But 1 centimeter square is equal to 10 to the power of minus 2 into 10 to the power of minus 2. That should be equal to 10 to the power of minus 4 meter square. And maximum flux density, that means Bmax, is equal to 0.6 Weber per meter square. Calculate the number of turns on the primary and secondary number of turns. See, in the given data is given as 2200 divided by 250 volts. This is called the primary induced EMF, and this one is secondary induced EMF. So use the formula. E1 is equal to 4.44 into Bmax into AN into F into N1. What is E1 now? 2200. That should be equal to 4.44. The maximum value of flux density is 0.6. The net cross sectional area is 36 into 10 to the power of minus 4. The frequency value is 50 Hz, as the frequency is 50 Hz. And we have to calculate the N1. So from this, I got it as N1 is equal to 459 tons. The number of tons on the primary side is 459. Similarly, use the secondary induced EMF equation. E2 is equal to 4.44 into Bmax into AN into F into N2. So the secondary induced EMF is given as 250 volts. As 250 is equal to 4.44 into, as B max is 0.6, and this is 36 into 10 to the power of minus 4. The frequency is 50. The number of turns I have to calculate. From this N2, I got it as approximately equal to 52 tons. The secondary number of turns is 52. The secondary number of turns is 52, and the primary number of turns is approximately equal to 459 tons for this problem. Okay, so the primary, see, E1 is greater, primary induced EMF is greater than the secondary induced EMF. That means N1 is greater than the N2. Then only the answer is correct. Otherwise, the answer is wrong if N2 is greater than N1. Why? Because the primary induced EMF is greater than the secondary induced EMF. And coming to the second problem, and this problem is repeated so many times, and also this problem is very important as an exam point of view. The maximum flux density in the core of a 250 by 3000 volts. This is low voltage and this one is high voltage. So low voltage winding means as 50 Hz. You should write it as a frequency is 50 Hz. Single phase transformer as B max is equal to 1.2 into 1.2 Weber per meter square. The E.M.F per turn, this is very important. The E.M.F per turn means E1 by N1 or E by N is equal to 8. That should be equal to E2 divided by N2. So we already derived E1 by N1 is equal to E2 divided by N2. Determine the primary and secondary turns. Determine the primary and secondary turns means N1 is equal to how much and N2 is also how much. So E1 is equal to 250 volts. These are the induced EMFs. But here in this problem E1 is less than E2. So use the same formula. Okay, 250 divided by N1 is equal to 8. So N1 is equal to 250 divided by 8. So 8 3 ja. So approximately equal to 31. And 31 number of turns. And E2 by N2 is equal to, the E2 by N2 is also 8. E1 by N1 is 8. So what is E2 now? E2 is equal to 3000 volts. So 3000 divided by N2 is equal to 8. So N2 I am getting 3000 divided by 8. So I got it as 375 tons. 375 tons. See, by seeing this data, you can tell that this is a step-up transformer. So previous problem is step-down transformer. So what is the next one? As primary number of turns is calculated, secondary number of turns is also calculated. The last one is area of the core. So E1 is equal to 4.44 into B max into AN into F into N1. The primary induced EMF is 250. That should be equal to 4.44 into the maximum value of flux density. So the maximum value of flux density is 1.2. I want to calculate the net cross-sectional area of the core. Frequency is 50 and the N1 number of turns is 31. So finally I got it as 0.03003 meter square. So this is our answer. The first answer is, what is the first answer? Yes, our conclusion point is N1 is 31 tons and N2 is 375 tons, and the third AN is for this problem 0.03003 meter square. So and coming to the next problem. the primary winding of a 50H single phase transformer, primary winding of a 50H single phase transformer has 480 turns and is fed from 6400 volt supply. That means 6400 volts we are giving as an input, means the induced EMF is 6400 volts, the frequency is 50 hertz, and the number of turns is 480. The secondary winding has N2 has 20 turns, N1 has 480 and N2 has 20 turns. Find the peak value of flux in the core. So phi max is how much? And the secondary voltage E2 is also, what is the answer? Okay, E2 divided by E1 is equal to N2 divided by N1. That is called the transformation ratio. What is E2? E2 we have to calculate. E1 is 6400, N2 is 20 divided by 480. So from this 24. So E2 is equal to 6400 divided by 24. So I got it as 266.667 volts. This is called the secondary induced EMF. And one more term also we have to find out, the peak value of flux. So E1 is equal to 4.44 into phi m into F into N1. From this phi max is equal to 6400 is primary induced EMF divided by frequency is 50, and this is 4.44. Number of turns on the primary is 480. So finally I got it as 0.06 Weber. So if you observe the problem to problem, the first problem is directly asking number of turns on the primary and number of turns on the secondary by giving primary induced EMF and secondary induced EMF. In the second problem, the EMF per turn is given, and then find the number of turns on primary and secondary net cross sectional area of the core. And coming to the third problem, it's very simple, and by using a transformation ratio you should calculate the secondary induced EMF, then after that calculate the maximum flux density. And the number of turns on the primary and secondary windings of a single phase transformer is 350 and 35. So now N1 is equal to 350 turns and N2 is equal to 35 turns. If the primary winding is connected to 2.2 kilovolts, primary winding is connected to 2.2 kilovolts, means E1 is equal to 2.2 kilovolts and the frequency is 50 hertz. Calculate the secondary induced EMF. Yes, E2 is equal to how much? It's very simple. E2 by E1 is equal to N2 divided by N1. From this, E2 is equal to E1 into N2 by N1. And what is E1? Primary induced EMF is 2.2 into 10 to the power of 3. And the N2 is 35 turns. And this one is 350. So I got it as 220 volts. The secondary induced EMF is 220 volts. Friends, from this EMF equation, definitely you may get 8 marks for derivation and 7 marks for problem. And this type of questions are repeated in universities examinations so many times. Okay. So this is the previous year question paper problem in the year of 2017. A single phase 50 Hz transformer has 100 turns on the primary, 400 turns on the secondary. That means it is a step up transformer. The primary winding has N1 number of turns, and N1 is 100, N2 is 400, and the frequency is 50 Hz. The net cross sectional area of the core is 250 centimeter square. The primary winding is connected to 230 volts 50 Hz supply. Determine the EMF induced in a secondary winding. So he is asking what is the E2 value and the maximum value of the flux density in the core. So we have a relationship E2 by E1 is equal to N2 divided by N1. So E1 is equal to 230 volts and N1 is equal to 100 tons. N2 is equal to 400 tons. So E2 is equal to E1 into N2 by N1. E1 is 230. N2 is 400 divided by 100. So 4 3 are 12. So that is 920 volts. So that is called the 920 volts. After that, he is asking the maximum value of flux density in the core. Maximum value of flux density in the core. So that is second question. The area of cross section is 250 centimeter square. 250 centimeter square. 250 into 10 to the power of minus 4 meter square. So 1 centimeter is equal to 10 to the power of minus 2 meter. 1 centimeter square is equal to 10 to the power of minus 4 meter square. Okay. E1 is equal to 4.44 into B max into AN into F into N1. Induced EMF is 230, the primary winding. 4.44 into B max I have to calculate. If the net cross sectional area is 250 into 10 to the power of minus 4. Our frequency is given as 50. The number of turns in the primary winding is 100. So 230 divided by 4.44. 250 into 10 to the power of minus 4 into 50 into 100. So I got it as B max is equal to 0.4144 Tesla or 0.4144 Weber per meter square. Tesla or Weber per meter square. So this is the answer. And then coming to the next problem, this is also 2017 November question paper. This problem came. The voltage per turn of a single phase transformer is 1 by 1.1 volts. So that is 1.1 volts. E1 by N1 is equal to E2 by N2 is given as 1.1. And the primary winding is connected to 220 volts. That is E1 is 220 volts. And the frequency is 50 Hz. The secondary voltage is found to be E2 is equal to 550 volts. Find the primary and secondary number of turns. Okay. So E1 by N1 is equal to 1.11. From this N1 is equal to E1 by 1.1. E1 is 220 divided by 1.1. So 220 divided by 1.1, that should be equal to 200 tons. E2 by N2 is equal to same 1.1. The EMF per ton on both sides of the transformer is same. N2 is equal to E2 by 1.1. The E2 is 550 by 1.1. So 550 divided by 1.1 1 is 500, I think. Yes, it is a 500 tons. It is a 500 tons. And he is asking the core area of the maximum flux density is 1.1 Weber. So B core area of a maximum flux density is 1.1 Weber per meter square. So you can substitute in any one of the EMF equation, either a primary induced EMF or secondary induced EMF. E1 is equal to 4.44 Bmax into An into F into N1. That is E1 is what is the E1 value? The E1 value is 220 is equal to 4.44 into Vmax into 1.1. Net cross sectional area is unknown quantity and the frequency is 50 Hz and the N1 is 200 tons. So if I am using the calci, 220 divided by 4.44 into 1.1 into 50 into 200. So 0.45 or 45.045 centimeter square. This is the net cross sectional area of the core. And coming to the next problem, the EMF per turn for a single phase 2310 by 220, this is E1 and this is E2. 50 Hz transformer is 13. So E1 by N1 is equal to E2 by N2 is equal to 13. So same question, same model, the number of primary and secondary turns. So E1 by N1 is equal to 13. From this, N1 is equal to E1 divided by 13. E1 is 2310 volts and E2 is 220 volts. 2310 divided by 13, that should be equal to 177.69, but generally it is approximately equal to 178 tons, because the tons are not represented in points. Similarly, E2 by N2 is equal to 13. From this you can calculate the N2 value. So E2 divided by 13. What is the E2 value? Is 220 by 13. So 220 divided by 13. So that should be equal to 16.92. That is 17 tons. 17 tons. Okay, after that the second bit is asking net cross sectional area of the core. So it looks like a same previous problem. Area is equal to E2 divided by, see, E2 is equal to 4.44 into B max into An into F into N2. Area, net cross sectional area, E2 divided by 4.44 into B max into F into N2. What is E2? 220. 4.44. The maximum value of flux density is given as 1.4 Tesla into 1.4. Our frequency is 50 Hz and the number of turns on the secondary is 17. 220 divided by 4.44 into 1.4 into 50 into 17. Then I got the answer is 0.0416 meter square. And these type of models are very important in an examination point of view.